everyone, it's NetMaven. Today we'll have a lab to do. It's gonna be Cisco Nexus Dashboard Fabric Controller for VXLAN Super Spine deployment. So, what is Super Spine? Super Spine is a device that is used to interconnect multiple spine leaf pods. So there are two options to configure Super Spine switches using the Fabric controller. So in this diagram, we're looking for the Super Spine connects to multiple pods within a site. Where Super Spine connects to external, we call it border super spine. So a border super spine handles multiple functions, including the functions of super spine, route refactor, RP, and then border leaf. So similarly, a border gateway super spine serves a super spine, route refactor, and RP, and a border gateway. Also, we have border gateway super spine. BG superspine is a node that interacts with the nodes within our site and with the nodes that are external to the site. So in this case, our leaf spine data uh, center fabric, it can be leaf, spine, and a separate device acting as a gateway to interconnect to the site. So these are two roles for the super spine. Let's take a look at today's diagram. We have multiple leaf spine pods within the same fabric that are interconnected through the super spine. So the same IGP domain extends across all the pods. What you see here is the IGP is extending the pod 1 and pod 2, the multiple pods, including the super spine on the top here. So with such a deployment that I provision the BGP route refactors and RPs on the super spine on the top here. So the spine layer becomes a pseudo intact connects between the leaves and the super spine. The super spine can host VTAPs if they have border functions. So we were going to become a VTAP if it's the border to the external on the other side. And we'll take a look at the other deployment model here. It's like we have the side one, and we have side 2. So is it possible to interconnect multiple VXLAN EVPN fabrics? We have EVPN fabric in side 1 and side 2. We interconnect them with my super spine in here. And the super spine itself is an external root server. In this case, the super spine must be part of an external fabric. Within the fabric, I use an appropriate IGP, that's IGP OSPF, the IGP IS underlay connectivity. So eBGP between the super spine layer in the external fabric and the spine layer in the fabric is a recommended way of interconnecting multiple VXLAN EVPN fabric. So I configure eBGP peer through the interfabric links and an appropriate mixed interface and eBGP configuration on the respective switches. What I configure will be eBGP connections on the physical interface, and through the eBGP or multi-hops will be a loopback interface dedicated to the super spine on the BGW inside one, and in the super spine we have a dedicated loopback interface for EVPN connections, and to the side 2 we have the same. The super spine will use next hop unchanged, so any saying routes update to the side 2, you'll keep using the next hop from the side 1. The the same thing from the other way. And we'll rewrite EVPN RTASN. So to do this is to we normalize the outgoing RTAS number to match the remote AS number. So we use BGP configure neighbor remote host AS. So in this case, we have 100. The routes from the side 1 to the side 2 will be converted to 100 when they're going out from through the super spine BGP AS. So this is second, the lab will focus on this way. The super spine is acting as a route refactor and RP point for multicast, serving the inside the side 1. Let's first verify the server IP configuration and connectivity. So let's log into my CLI, ifconfig to see the server 1 IP address and server 2, server 3. So let's go back to server 1 and we're gonna ping server 2, ping server 3, ping the external IP. So the fabric is not configured, so ping is not successful and it's 100% packet loss. The goal of this lab is to have the connectivity working between the servers and the external resources at the end of the lab. We'll first configure the VXLAN VPN fabric on the greenfield. What I mean greenfield is this all greenfield site. We'll first configure fabric. Log into my Nexus dashboard. The dashboard has installed a service, a fabric controller. We'll navigate to the fabric controller and open it up, and we're gonna go LAN and fabric. We'll first create a new fabric. The fabric name we're gonna say VXLAN EVPN greenfield site 1. I'll choose a template. Template we're gonna say easy fabric. In the general parameters, enter the AS number 65001. Click Add Advanced. Well, notice the site ID has changed to 65001. Keep scrolling down. Here, in the greenfield cleanup option, we'll enable it to clean up all the devices. Scroll up, navigate to the configuration backup. We'll make a Harvard fabric backup and click Save. Now we have new fabric VXLAN in greenfield site 1. We'll go double click the fabric, navigate to switch, and we're going to add a switch. To find a seed switch, enter the IP of the seed switch. Uncheck preserve config and or to discover switch for greenfield site. Uncheck all the device except the external router. Click here, add a switch. So when adding switch complete, I will see the status showing switch added. Let's close it. So the next step what we should do is to assign the roles for spine. I use the spine role. Fix that. And let's select the super spine and we'll set a new role. We say this board gateway super spine. That's the super spine interconnection within the fabric. Select that. Now notice the spines are in row of spine, super spine, and row border gateway, super spine. So we'll go to the top action where say we calculate config. So I'm seeing a lot of pending configuration. That's per view. It's taking in a lot of device configuration here. I'm seeing the interface to the super spine and the ping for multicast. And all the interfaces are changing to MTU 9216. Interface to the leaves. Also the IGP OSPF configuration. The loopback for internal IGP. And multicast configuration and RP. Basically, we're seeing this taking in the IGP VXLAN configuration. All the future here is enabled. Close that. Click deploy. So you see the progress of commands running when the deploy completes. Well, notice status is changed to success. Now I'm seeing the config it's being deployed. We'll close this. The next thing we're going to do is configure access interface to the servers or navigate to the interface. And then interface, I'll make a filter whilst the device name is leaf-1. And the filter, I'll find the interface to the Ethernet 1/2. Check this interface. I want to take action to edit it. After the interface got deployed, we're going to repeat all the same configuration to the other servers. Make VLAN 230. This leaf 2 will now also move to 230. And leaf 3 for server 3 is different to VLAN subnet, so we'll move to 231. So let's find out this device. I'll double check the connections, check configuration. All configuration are in synchronized. Let's check here. Go back and I'll see the networks. They are intact. So BF1, let's go to my server 1. I want to ping the server 2. And let's pin server 3. So I got a response and I just wanted to ping the external. It's not pingable. So that concludes creating and configuring the VXLAN fabric on the greenfield. The next thing we're doing is create and configure external fabric. The external fabric represents the connections from data center to external worlds like WAN or internet. We're going to navigate to the LAN and fabric. We're going to create new fabric. The fabric name we're going to use is the external. And we choose a template as a external fabric just right here. Click it. The fabric AS, so I named it 6005.002. If I can monitor around, check it. Alright, then we'll just save it and to create the fabric, external fabric. Double click the external fabric and we're going to add our switch. For the seed switch IP, 198.18.4.205. It's still in SOS. And we'll go add discover switch. So when discovery switch is showing is the external router, we're going to add this switch. After this switch that added, we'll close the tab. Now back to switch. I'm going to assign a role to this router. So we'll name it as an edge router as an external. Select the edge router, action, recalculate config to make sure that everything is put in the router. I'll wait the deployment to complete. Let's close it. Now the status is showing OK and a success. Next up, we'll create inter-fabric connections, IFC. So the inter-fabric links to establish connectivity between the VXLAN EVP and greenfield site and external fabrics. The external fabrics to the VXLAN and the fabric, external fabric. What I'm going to do is to go to the LAN fabrics. We'll click it, LAN fabrics one. Still go to my EVPN fabric, greenfield. Under links, we'll make an action to create a new link. We're going to create a first link. The name type we're going to be inter fabric instead intra fabric. We have light. So link template. We're going to keep using this kind of external fabric setup, and the source fabric destination. The source device, we'll be choosing super spine. Interface, we'll be using 1/1 on both super spine. So destination fabric, well, we want choice the external router is 1/3 and 1/4. So we're gonna make 1/3. The source BGP-SM and source IP mask. We'll make a /30 destination. Link MTU 92.1.6. That's fine. We'll click save it. It was added successfully. That's what we want. Now we're going to add a second link into our fabric. Source spine 2, super spine 2, 1/1 destination. That's device. We'll make 1/4. Okay. Everything looks very fine, and I'll save it. Now create two links. One, go to the VF and click VF attach. We're gonna find out VF1 and super spine 1 is not deployed yet, so we're gonna make edit. So this time we're gonna attach it. VLAN leave as default 2000. Extend the field. What we want is VF light. The other, you can expose the other options. We go down to the extension and attach to the link we just created, and the door 1 queue ID, I'll make 20. That's it. Let's click save and save. We'll attach the link. Choose the spine to the VF1. I'm gonna add a second link to attach. Come out of here, attach .1 queue ID, which make 21, and we'll save it. Click save again. I'm seeing two pending on the super spine, 1 and 2. What we want is to click the action on the top and we'll deploy the config. And click deploy. Now let's close it. As of right now, we configured the inter-fabric links and configured VF attachments. We're now to configure external router. So we'll exit it. The external router is in the external fabric. The external fabric, we're going to go to the policies. Click the policy, external fabric, under policies. We'll add one policy. going to select external router, select it. I'm going to pick up a template. Template, we're going to XVF light JSON. Select it. The first interface I'm going to configure is the Ethernet 1/3 on the external router, and we're going to enter the interface name. Remember, it's VLAN.1Q20. This is 20. Q20. This will be Q21. Right. Okay. I'm gonna encapsulate VLAN 20 DVF or VRF1. Enter IP. We'll find with MTU the neighbor and AS number. And click save. Not a routed interface. So probably we need to exit it. I'm gonna find out the interface. Showing me 1/3 and 1/3 auto think. We need to recalculate. Lines. Okay, I'm going to shut down no switch ports and deploy the ports as a routed interface. We're going to close it. Then we'll go to policy or add a new policy. Click save. Now it's working. I'm going to add a second policy. Instead of 1/3, or you choose 1/4. Encapsulate VLAN 21, VF1. Okay. Click save. Take action. We're gonna to find out. Okay, anyway, take recalculate. I'm gonna find a 30 lines configuration to add, and it's adding the sub interface, encapsulate the VLANs, and set up the BGP neighbors. And IPv4 unicast to the super spine. Click deploy. Check all that. Close. We're going to add one loopback interface. The loopback interface, you're going to simulate an external route 8.8.8, loopback ID 8, and for the VRF1, we're gonna to enable interface checked. Everything else looks fine. Save it. Gonna deploy this interface. So that's got deployed. We need to navigate policy again. We're gonna add a policy is to advertise the BGP. The policy we're gonna pick out of this, the BGP VF network. Select that. The AS number we know is 65002, and VF1. I'm going to advertise 32 host route 8.8.8.8, and we're going to save that. So we'll take action, recalculate. Check adding a BGP and address should be to the BGP 8.8.8 route. Deploy that. Now we can go to the serve one. Let's go to serve one. Let's ping 8.8.8. That's right, we can ping it. So I configured external connectivity from the DC fabric. Let's now close it. We'll go to topology, and in the topology we'll check the site one. I'm seeing the site links to the external fabric. To the spine 1 and spine 2. So that concludes all the labs. Thank you for watching.